Hello everyone. We want to look at the electric field of an infinite line of charge. And it's a very interesting topic on the electric field so that we want to look at. Now let's start right away. Now let us have an infinite line of charge. Line like this of the infinite line of wire. It has charges. It's a line that has charges. Having it, let's say from this point now, or let's take a point here. This point we have taken, let's call it point P. And having a distance of what? Of y. Let's say it has a distance of y from here. That means that is the distance. Now this is point P. Now this infinite what? Line of wire. Let's say it has a negligible thickness and constant line density. What is line density? The line density is equal to what? Charge over what? Over length. Now, for easy analysis, let us cut a small element from this particular word. Let's cut from this wire. Let's cut a small element from this wire and call this one the X. We cut a small element from this wire and call it the X. Now let's say that small element that we cut has a what? A charge of what? A point charge. Let's call it a point charge. Let's assume this is a point charge of what? The Q. And has a distance of what? From the point we are considering, let's say R from there. Now that means from this other point it will be what? X distance from here. That's what? The small element, this is small element, it has S distance from here, and that's Y, this Y, which is the original distance from the point to the wire. And let's call this place theta. So now the electric field, because if we want to calculate electric field at this point now this is a point charge. It will reflect, the point charge that is now here from the small element, which is the Q, we now, don't forget this wire has a constant line density. Line density, which is what? Charge over length. Now let's take what is the line density of this small part of the wire? Because everything is about lambda, which is what? Which is constant like this. So for the small part alone that we cut, the line density will be what? The Q over what? The X. That's the line density of the small element that we make out of it. Because we can calculate for this, we can calculate for everything. Now, the electric field of this one will what? Is this one, the Q that we are looking for. Now, what about it will have what? Along the Y, that means the Q along the E along the Y, then we have it what? Resolve along the X. We're going to have what? This electric field of this small element that has a point charge of this. The point charge which creates electric field this way, we have what? Is horizontal resolution and vertical what? Resolution. Now, having done that, don't forget that the Q will now be equal to what? If you make what? The Q will now be lambda the S. Now, remember that the infinite line of charge, the line charge of wire has the what? A point charge of the Q equal to what? Lambda, because multiply from here. Now, having known that, the next thing to do is that we have gotten our what? Our line charge. Now let's resolve the electric field that we got here. If you resolve it along the Y, You are going to have it. If you resolve the E along the wire, there is theta. We take it as theta. Here will also be theta, because it is what vertically opposite angle. So this one will be what? The E, if I resolve this electric field to the vertical, the E cos theta, then along the horizontal, what? The E sin theta. Now, having done that, what about the electric field itself? Electric field itself is equal to what? It's equal to dq over what? 4 pi epsilon naught what? R. Electric field of this what? This electric field having a distance of what? R from the point. From here to this place is R. So if you want to calculate the electric field is what? Normal electric field formula is dq over 4 pi what? Epsilon naught. Now, having known that now, what we're going to do next is what? Let us work with this parameter. Now, if you check the integral of what? Of this E, we want to find the what? Electric field from minus infinity to what? Or from minus infinity to plus infinity. It's actually giving us electric field, because if you integrate this one now, let me just say the E now. If you integrate the E, you are going to have E. Now let's take the E as what? The Q over what? 4 pi what I'm saying now is that, look at the board. This the E now. What is the formula for the E? The E along what? Now, remember, for us to calculate, I want to analyze something here. There's something I need to make you understand here. Now, remember the E now is the electric field of this what? This point charges here. Now, but remember that what? If you want to actually calculate the electric field of this long wire from here, it has to be this along this direction. It has to be along the direction. So your E should be what? The EY. That is what you are going to do. Starting from minus infinity to plus infinity. That is what you are supposed to use. Because why? This is it. This is the actual distance from the what? From the wire. And that means that we are going to consider the resolution along the Y component. That's what we are going to consider. Remember, we have resolved what? This particular what? Electric field along the Y as this. So which is set as what? Minus infinity to plus infinity. Because it's an infinite what? Line of charge. So that means infinite line of wire charge. So that means this one will have what? The E cos theta. That's what I want to use now. So that's what we are going to resolve. That becomes our electric field. Now, if we want to now resolve it, what do we have? Now, in magnitude, which is equal to E, it will now be equal to what? Minus infinity plus infinity to infinity. Is simply as what? Now, remember that this can also be written as what? Lambda dx divided by what? 4 pi epsilon naught what? R square. Because in place of what? Point charge, this one I can replace that one there. And which now becomes what? Lambda dx over 4 pi epsilon naught what? R square, which is dE, then cos theta. Now, having done that now, you can now what? Do something here. First of all, what is your R square? R square can be gotten from here. This is a right angle triangle. This is what? Is meeting this wire at right angle. So that's why if we check, we are using this electric field because it's a vector quantity. So it has to be, we are looking at the octagonal part of the electric of the field to the wire. So in that case now, we're going to have what? Y square plus what? S square by Pythagoras theorem. This is what? Opposite, this is adjacent, and this is hypotenuse. So that is R square first. Then another thing again you must understand is that we know that tan theta equal to what? X over y. Take note of that. Opposite over adjacent. Now this is an integrand of odd function. So how do we turn it to even function? If we have what? This integrand of what? F of x dx is simply as what? 0 to infinity of 2 f of x dx. So this is what we are going to turn it to. So we want to change this one to what? Something like this now. So it becomes what? Starting from infinity, because all this one is x. Don't forget, this is x. Upper limit is along the x. So we are doing that with respect to x. So this one now will now be turned. We want to remove from minus infinity to infinity to what? 0 to what? Infinity. Then we'll now introduce 2. Because this function itself is a what? Is an integrand odd function. We now turn it, we use this one to replace this with the introduction of 2. So you have 2 dx cos theta divided by what? 4 by epsilon naught r square. R square will now be what? S square plus y square, or y square plus s square, anyone. So this is what we are going to have now. Remember that I said tan theta equal to opposite over adjacent, which is what? This. Now that means dx over the what? That means if you make what? X is subject to formula, you would have x is equal to what? Y tan theta. And even if you want to solve for what? This is x. If you put what? If x to be what? This is x. This is x. If you put x to be infinity here, and let's solve for theta, because we are not changing our function. We want to change this function of x to become theta now. Everything will be changed to theta now. We want to replace it. That means even this x upper limit and lower limit and upper limit will change to even theta also. So what is the theta of infinity? When tan theta equal to s over what? Y. It means that if I put what? Tan inverse of what? Infinity divided by y of x. What do you have? You are going to have what? 90 degree. Because infinity over y is equals to infinity. Tan inverse of infinity is 90, which is pi over 2. Then x is equal to tan inverse of 0 divided by y will give us 0. Tan inverse of 0 is 0. So I'm replacing this one with pi over 2, which is 90. And I'm replacing this one with 0 degree, which is what? 0 also. Then in place of y, x, I will replace y tan theta. Then in place of the x, I have to differentiate this function. If I differentiate, you have the x over the theta is equal to what? Y sec square theta. So y sec square theta. So in this case, the y sec square theta is equal to what? The x over the theta. Because if you differentiate tan theta, you are going to have what? Sec square theta. So in that case, you are going to have what? The x is equal to y sec square theta, the theta. It's very interesting. Very, very interesting. Now, another thing again you have to notice here is that I can replace the x here. Then I can replace my y, x to be what? To be replacing. Like everything I'm having is in terms of theta. What I'm saying now is that now, some people wonder how does this 2 come here? Don't forget these 2 come into play because I've changed all these lower limit to 0 and upper limit to what? Infinity. I change it from what? Because they have it's the same thing according to integrand what? Odd function. Now, So let's place it. Let's place that. So that means this one will now be what? 0. Why this one will now be pi over 2? Pi over 2 is getting very interesting. Now this one will cancel this one, remaining 2. So we are going to have what? Something like this. Okay, that means E becomes what? Pi over 2 and lambda over what? 2 pi epsilon naught. That means lambda. This one now will cancel this one. So lambda over 2 pi epsilon naught we go move to the back of the integration. So let's deal with what we have now. We are going to have what? Cos theta dot the x will now be replaced by what? Y sec square theta. The theta divided by what? Then in place of this, I'm going to put what? Y tan theta all what square plus y square. Don't forget, my x is equal to what? Y tan theta. Remember that I can factorize out from here. So I will factorize lambda over what? Is equals to what? Cos theta. This is what? Pi over 2. And here is 0. See pi over 2 here. Pi over 2, there is 0. Is equal to what? Cos theta dot y sec square theta. The theta divided by what? Now, what is common? What is common there? We can bring that as y square tan square theta plus y square, which we can factorize as what? Pi over 2, 0. Now what? Cos theta dot y sec square theta, the theta, divided by what? Y square into bracket what? Tan square theta plus 1. Oh God, this is interesting. Then E is equal to what? Lambda over 2 pi epsilon naught. Now, having gotten to this point, you can see that something can be eliminated. Tan square theta plus 1 is equal to sec square theta. Is equal to sec square theta. So that means I can what? Write it as pi over 2, 0, cos theta dot y sec square theta, the theta, divided by what? Y square sec square theta. Because tan square theta plus 1 is equal to what? Sec square theta from identity. So this will eliminate this one. This will eliminate this. We will have only y remaining. So this, there is lambda over 2 pi epsilon naught equal to E here. So what we have left is what? Y will be remaining here. Let's move it to the back because it is a constant. So pi over 2, 0. What will remain here is what? Cos theta the theta. So if we integrate cos theta the theta with respect to what? Theta. Upper limit pi over 2, lower limit 0. You are going to have it as what? Cos theta. If you integrate cos theta, you are going to have sin theta. Or what? Pi over 2 upper, lower limit. Then we have lambda over 2 pi epsilon naught y. It's equal to E. Now, I haven't done that. What we want to do now, next, which is the last part, is that to get our final answer is this. If you put your word, E is equal to lambda over what? 2 pi epsilon naught y with upper limit of sin 90 with sin pi over 2 minus sin 0. Pi over 2 is 90. Sin 90 is 1. 1 minus 0. This sin 0 is 0. So 1 multiplied by everything, I would have E is equal to, therefore, ladies and gentlemen, 2 pi what? Epsilon naught y. We assume that this is taking place in air. That is why this formula will remain like, will be like this. But if it's occurring in a medium, if this process is occurring in a medium, it becomes E equal to what? lambda over what? 2 pi epsilon what? Y. So, which is the same thing as what? Lambda over what? 2 pi epsilon naught, epsilon r, epsilon naught times y. This one is what? In what? In a medium. So this is the formula for electric field in a medium, and this is what for what electric field of an electric field intensity of an or due to infinite what line of charge of wire in air. So in that case, we are able to establish and what get the what a formula for what this particular what in electric field of due to what an infinite line of charge on the wire. So in this case now, I believe I've been able to do a lot to convince you, that not to confuse you about what the formula for what. Sometimes in this case you can use R, you can use X, you can use anything. But don't forget that why this is like this, because epsilon equal to what? Epsilon R times epsilon naught. What is epsilon R? It's what we call the relative what? Permittivity. So is what? Is going to be given to you if it's in a medium. Then this one is what? Permittivity in free space. In what? In free space. So it's constant. For permittivity in free space, it's always given as 8.85 times 10 to the power minus 12. It's always given in question. Coulomb square per Newton per meter square. It's always given. So this one, the lambda there is what we call a linear charge density. We have what they call linear charge density. We have area charge density. Area charge density, charge over area. We have volume charge density, is what? Volume over area. So this I've been able to do to explain to you. Please try and subscribe if you enjoy the video, and also what? Ensure you click the notification button to get information from us, to get more videos from us. Thank you very much. God bless you.